The 90% committee, that's. And then 10% of the cost.
No, 90% of the cost, 10% of the building. Okay, so.
What?
Oh, the cost-
Y'all are so weird. Just saying.
Yes.
I love being weird. You're weird. Here.
Oh.
And then. They're tacos.
But.
Tacos. You play the tea.
Yes, sir. I don't know. He's adult. I know that. I don't know how. I don't know how old. I just know it was an adult. Yeah, it's pretty cool though.
Oh, yeah, sure.
It's working. Just to work. I really do.
Back to them.
As you do.
And he's got the tacos. Tacos. Got the tacos. The potato naughty. No, it's the Illumina bud. We voted on this. Yeah, but we put the coin. It voted on. But the votes were in favor of Illumina bud. Yeah, but the coin was in favor of potato naughty. Alex, don't make a deal. What? What about potato naughty?
That sounds like something.
All right, you good?
Don't be.
All right, gang, so let's go ahead and get started. We got lots of opportunities for you to answer today. Oh, that's a problem. And get some coinage, to get some goodies, all that kind of stuff. Lots of opportunities. I just want to see if I can make this work. It never seems to want to do what I want it to do. Yeah, I'll play with it later. Okay, so today we're doing volcanoes. Next week, what are we doing? Who knows? Who's looked ahead?
Earthquakes.
Anybody ever experienced either personally? Anybody ever experienced either?
There might have been an earthquake or two that we.
Yeah.
that they're right.
We've had some earthquakes come through here for sure. They're usually not very big, but we've had them. And sometimes you feel it a little bit. All right, leave the potatoes behind. So sometimes you feel it a little bit, sometimes you don't feel it at all. I felt it a little bit. I have a friend that lives in Anaheim. So every time it's on the news that there's another earthquake out there near LA, I'm texting her, I'm like, are you okay? Are you okay? And she'll be like, yeah, I broke a teacup or something, because she has a teacups collection, or she'll say, yeah, I shook for a bit, but I'm fine. That would scare me. I wouldn't like it. All right, so we're going to talk about volcanic activity. And since we're probably going to have a little extra time, we will watch some of that video, and I'll share that link for you guys too. It's pretty interesting. And all of your parents, well, most of your parents are probably going to remember this whole eruption, especially if you were living in the US at the time, and or if you knew anybody out there, it would have been even worse. The good thing about the Mount St. Helens eruption is they suspected it was coming. I mean, they pretty much knew it was coming because there had been smaller, signs, and the US Geological Survey knew it was coming. So USGS was telling everybody to get out, get out, get out. And a lot of the people were safely evacuated, but the damage to the area and property was just unbelievable. All right, so volcanic eruptions. So in the last 10,000 years, more than 1,500 major volcanic eruptions have been recorded. So where and why do they occur? Yes, sir.
Probably mostly along fault lines.
Yeah.
There have been some volcanoes that pop up in the middle of plates, but it's almost always along fault lines.
And that makes sense, right? So let's talk about magma a bit. First, we got to kind of look at how it forms, and we've been through this. You guys kind of know this whole stuff already, right? You've got pressure and you've got heat, and you get all this molten rock, and it can make all kinds of shapes underground too, right? You can do laccoliths, batholiths, sills, dikes.
Isn't presence of water affected?
Yes, the presence of water will affect how the volcano erupts. It'll also affect the type of magma and what kind of igneous rocks form from it. Now, I'll mention this now, and it's probably going to happen a couple times over the next few weeks to some of you. Some of your books have a slightly different configuration than everyone else's. James has discovered this already. Okay, so the last time I taught this class, we had an issue where some people, like it would say, Yusuf experienced it this week. It'll say like, read section 18.2. That's what the notes will say in your binder. But when you get to 18.2, it's not exactly the same in your book, but it's going to be the same in other people's books. Just know that the information didn't change, but the way they configured it did. So you might have to kind of go to your index or whatever and look up the topic and see what page it's on, because they might have ordered it a little differently. When textbooks do that, sometimes it's because somebody complained about something and they wanted a second run printed, so they printed them slightly different. Sometimes it's because different school districts requested something different. Specifically next year, when we do physical science, the physical science textbook you will use is specifically the Florida edition. They're all slightly different, but I use the Florida edition, and there's reasons for it, but just be aware. So for the next couple of weeks, if something looks wonky, don't panic. It's just that your book's a little different. And if you intend to turn your book into me at the end of the year, like to donate it, or if you've rented it and you're giving it back, if you can remember to let me know, like put a sticky note on it or something, that way I can let whoever in the future has it know before we get to the problem again. So recall, magma is a mixture of molten or melted rocks, suspended mineral grains, dissolved gases found deep beneath Earth's surface. So how does magma form? So it usually forms between 800 and 1200 Celsius, which is 1600 and 2400 Fahrenheit. I don't think any of us can really even conceive of how hot that is, because we've probably never been near anything that was even radiating that sort of heat, right? So the temperature and the pressure on the rock, along with the amount of water, as Yusuf pointed out, in the rock, determine at what temperature the rock will melt. Those with water in them tend to melt. How? Do we know? Right. All right. So pressure and temperature. Whoop. All right. This is what we need to remember about the relationship between pressure and temperature. As pressure does what on the rock inside the earth, the temperature is going to do what? All right, Yusuf, you tell me.
The pressure is going to increase the rock's melting temperature.
Okay, so as the pressure increases, the temperature on the rock will increase. All right, and then hang on, we'll come back to that. So the deeper down into the earth you go, the higher the temperature. So yes, that's exactly right. So what kind of relationship is this? What do we call this, Bailey? Hand it in. You remember?
Direct.
Huh?
Direct.
Direct. That's it. Okay, that's what we're looking for. So there is, that's good, Bailey. That is hand in hand. So there is the idea of directly proportional, and there is the idea of inversely proportional. Inversely proportional would be like when one thing goes up, the other thing goes down. Directly proportional is when one goes up, the other goes up. Have you ever, this is a weird thing, but have you ever taken an ice cube into the shower? I know that sounds crazy, but I know, have you done it? So like when I was a kid, I would be carrying a cup of ice water, and I just put it on the edge of the, edge of the tub when I was getting my shower, so I could take a sip because I was still thirsty or whatever. But one day I took one of the ice cubes out, and I had those sliding glass doors that we all used to have in the 80s. And I found that if I ran the ice cube along it, it would melt the little ridge into it. But if I pushed really hard, it would do it really fast. So you're increasing that pressure there, but it would like cut a little groove into the ice cube. And I would just stand in the water, and my mom would be banging on the door about me wasting water, but it's kind of fascinating. So yeah, that happens. So water and magma. So we talked about this. If a rock contains spaces that hold water, the rock will melt at what kind of temperature, Bailey? Higher temperature, lower temperature. Okay, so it's going to melt at a lower temperature because the water in it is there. So that's where we're headed with that. So it's going to melt at a lower temperature than normal because the water found inside the rock helps it liquefy as it heats up, which makes sense, right? When you put water in things, it tends to help them liquefy, right? So we have different types of magma. Mainly, we've got basaltic magma, andesitic magma, and rhyolitic magma. And you've heard these words before because we had rocks that were like this. Well, because those are the kind of rocks they form. So we have to review rocks for just a minute. This picture reminded me so much of that beach I went to in Nova Scotia with all those little rocks I put over there, but they were all so different. I don't know where that came from, but they're really pretty. So igneous, those are the rocks that come from cooling magma and lava. What are other kinds of rocks, people? All right, Liam?
Sedimentary and metamorphic.
Yeah, okay. So the sedimentary ones are coming from sediments, obviously, and the metamorphic ones come from heated solid rock, right? All right. So here we go. We have a magma type and the solidified volcanic rock. Now, these are going to be basically the same word. Remember, we have andesitic, rhyolitic, basaltic. So what kind, if it solidifies underground, makes gabbro? What time makes diorite? What kind makes granite? Bailey, what do you think?
I forgot the word.
Okay, that happens. Do you have a guess?
Rhyolitic?
You think that which one is rhyolitic? The first one, second one, where are we going? Let's do the first one. So what's going to produce gabbro? It's going to be about 45 to 50% silicon. Okay.
I'm gonna guess basaltic for for gabbro.
Okay, basaltic is the guess, and that's right. All right. So this is the stuff that is lower in silicon, but it's higher in iron. And this makes sense. Think about this. If it's higher in iron, magnesium, calcium, why, if it's higher in these things, is it going to be lower in silicon? What do we remember about silicon and melting points? And cooling points.
High silica, high melting and cooling point.
Right. Remember that the silica stuff cools last, right? So it's going to pick up these other things. If it has more silica, like right here, it's going to have less of the other stuff in it because the other stuff is already solidified, right? So how about diorite? What makes diorite? Bailey? There you go. Very good. Andesite. So your andesite is going to make your diorite. And then our last one is granite. So that's going to be Liam.
Rhyolitic.
There you go. That's all that's left. Rhyolite. All right. Rhyolitic. That's where we got. So this is the kind of magma we have. Now, each of these kinds of magma is going to have a different viscosity. Low viscosity, intermediate viscosity, high viscosity. Somebody remind me what viscosity is. Yeah.
Viscosity is like how it tends to flow.
Yes. How something flows. All right.
Or another way to put it is the thickness of a liquid.
Yeah. Okay, good. So low viscosity, intermediate viscosity, and high viscosity. So think about this for a minute. If something has high viscosity, does it pour easily or less easily, Drew?
Pours easily.
If it has high viscosity, it pours less easily, right? Okay, so why? What's here? Why is this stuff really viscous?
Because there's a lot of silicon.
There we go, because there's a lot of silicon in it. All right, so moving on. Choo-choo. I clicked you. There we go. So here we are. Oh, shoot. I wanted to do those differently. Fast. All right, so typically form, in the upper mantle. Rocks in the upper mantle begin to melt, and it tends to be fast moving and relatively quiet as it erupts due to its low gas content. So this is basaltic magma, quiet but fast moving. So this is the stuff that rolls along the surface of the earth, but it's not like bang, 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 because there's not a lot of gas in it. And then it's often associated with what kind of volcano? Where do we find basaltic?
Shield volcanoes.
Shield volcanoes? Do you have another guess, Alex?
Say shield.
All right, you're good. So shield volcanoes, right? That's where we find our basaltic magma. Yes.
So I watched this video on YouTube one time, and they're playing hockey like with iron with things on this.
With pucks? Wow, that's a little wild. I've seen videos where, I've seen videos where people go to like down and look down in the hole. I'm like, no, dude. I know. So how about our andesitic magma? So andesitic magma is made in subduction zones and is typically about what percent silica? Do you remember? We looked at it a minute ago. Do you remember?
Like 55 to 65%.
Okay. It's a little, right in there. That's really good. Right spot in the middle. And then, that tends to erupt at a medium pace, and it's often associated with what kind of volcano? Bailey. Composite volcanoes. All right. Cone in this case. So these are the cone volcanoes. Cone volcanoes form from a lot of ash. A lot of the times ash just pops out.
Cinder cone?
Some are cinder cone. Yeah, those are the ones that are really ashy. So a rhyolitic magma. Now, these are the ones that are like big time scary. Your rhyolitic magma is thick and it's slow moving. Why was it thick? What was it full of? Hyper silica, right? So that silica stuff is super viscous. All right. So it's filled with gas and water, and it tends to be really what? Because your pressure's building up. What does it tend to be? Drew? Dense. That's a good word. What else?
Explosive.
Explosive. It does. Okay. It tends to be really, really explosive. So think about this for a minute. Hold on. Think about this for a minute. You've got really thick magma. All right. And you've got lots of gas in it. This would be like if you're boiling, anybody ever boiled sugar and see how thick it is and it starts popping? All right. So lastly here, what kind of volcano? Okay, positive volcanoes. Calderas is often, the calderas, remember what the calderas is, like the big whole thing. And that's because these are the guys that go boom, like in this picture.
Another thing is that this reminds me of our river rocks. Never heat a river rock. It'll explode.
Why is that?
The water in them.
There you go. They
They'll
got water.
To explode. That's why you don't use river rocks for making campfires.
Right. And that's why, for example, when I took that skull that I found, I soaked that skull for about 20 hours, I guess. And then this morning, I soaked it in. You have to be careful if you bleach it because it can mess up the bone. So I did a little bleach, more peroxide, a little soap, little toothbrush, put it in some warm water. I rinsed the water out and restarted the diluted peroxide several times and diluted bleach once. And then this morning I rinsed it off entirely and then I popped it in the oven, but only at 200 because that's really low. And what does that do? It evaporates the moisture out instead of exploding it. Yes.
It is also below the boiling point of water.
Yes. So it's so it's not going to go kaboom, right? Yeah, exactly. I don't want my bones to explode. So viscosity refers to the rate or speed at which something will flow. We were talking about how something flows. It's actually like the speed. So if something has what kind of viscosity, it's thicker and slower. What do we call that? Bailey? That's high viscosity, right? Okay. Give me an example of something in your life that has high viscosity. Honey.
Syrup,
Great example.
syrup,
There you go. Corn syrup.
maple syrup.
Yeah.
Another
All right. What?
thick water.
Thick water.
Yes.
Oh, Drew's got soap over there.
Water.
Hand soap. That's a good example too. All right. So
Shampoo.
if something is said to have low viscosity, the thinner and what? What? Faster. The thinner and the faster it's going to be. Okay. So what's something in your life that's got low viscosity?
Water.
Piper. Water. What else? You come up with something else. You can do it. Which thing? Low viscosity. Water. What else? Juices and stuff like that. Yeah, perfect. All right. Oh, okay. Now Drew's holding up cooking oil. Now cooking oil is going to have higher viscosity than water, but lower viscosity. Yeah, lower viscosity than the hand soap he had up a minute ago.
Air.
That's a good one.
Wow. Air.
It's a flow. It does flow.
And it has more
You are correct.
viscosity. I am correct.
You always have to remember that gases and liquids are both fluids, and the same laws of physics are going to apply equally. So when we get into physical science next year, that's going to come up. So just keep it in mind. So now we're going to talk about intrusive activity. Now remember, extrusive is when it comes to the surface, right? So intrusive is before it has reached Earth's crust. So what are we dealing with here? So density and movement, let's have a look. Because molten rock is nearly liquid compared to the solid rock around it, it's going to be less dense. And it says that it wants to move upward. Really, what's happening? Somebody explain to me, what does that mean? It wants to move upward. Drew.
Because it's like putting oil on top of water.
But why does it?
Water's going underneath of it. It's
Okay.
being pushed up. It's that the soil and the rock around it is going underneath.
Because it has to do with density. Correct. Okay. The more dense the matter, the more effect gravity will have. So if you have a very dense rock, it's going to be pulled towards the center of the earth. And if you have less dense molten rock, that solid rock that's coming beneath it is actually going to push it up. You have to remember when you're thinking scientifically that molten rock isn't making its way up because it wants to. It's being pushed from what's going on below, right? All that other stuff is falling. And when you have something rising and then something falling in a fluid, you have what? What? Oh yeah. What do you have? Yeah, your lava lamp.
Convection.
Yeah, she pointed out lava lamp. Yeah, convection current. That's what it is. All right. So this is exactly what we did last week, right? All right. So if you look at this picture here, you've got basaltic magma down here and rhyolitic magma up here. And it says small amounts of basalt magma may eventually reach the surface and extrude as lava. But heat from deeper basalt moves upward and causes overlying crust to melt to produce rhyolitic magma that may eventually produce volcanism at the surface. And then it talks about how as things lift up, it changes sort of the ordering of how the molten rock is down here. So also what happens when magma flows upward into the cooler crust? The process is intrusion, right? So this is all intrusive. Once it comes out here, you got extrusive, but everything below the surface is intrusive, and you got a lot of movement down there. So we got different types of intrusions too. So magma can force the solid rock to push apart and create fissures. Fissure is a word you'll hear often. A fissure is any kind of like a crack. And you'll hear that word when you're talking physical science, you'll hear about fissure, obviously here. Also in biology, you have body parts that can have fissures. Some places you really don't want to. Yeah, they don't usually use the word with bones, but yes.
Or heart muscles.
Yeah, heart muscles.
Skin.
Y'all are gonna laugh at me, but probably where you'll hear that word used most medically is anal fissures. Does that sound like fun? Everybody want that? Ooh, little tears. Yeah, that can happen. That can happen. Not fun. Isn't that fun? See, now everybody's paying attention again. Those of you that were a little sleepy are now awake. See how that works? See how that works? Don't forget, I got my Nerf gun now. All right, it's right over here. I can grab it if I need it. Yeah, no, you probably don't want to see. They're probably pictures. Yeah. All right, so magma can contact the upper solid rock and cause pieces of it to melt and then fall into the magma pool. So as this magma, this less dense magma is being pushed up because the more dense rock is falling down, it's melting what's above it. And those solid chunks are falling through it and back to the bottom, which then forces it up even more, right? So as it continues to melt stuff, the solid pieces continue to fall and it makes its way up to the surface. So it can immediately melt the rock into which it flows. Super fast. So plutons. Plutons are intrusive structures that have been formed by magma and solidify. Remember, we talked about Stone Mountain being a type of pluton, right? And then, are my birds interesting?
No,
What is it?
there's something like this big up the tree.
What's a squirrel?
It's this big. It's not. small.
Yeah, he's a big squirrel. Weird. And what area is he?
What tree?
It's which tree?
Here, wait.
Oh,
That bird?
Oh, there.
No, hold on. That cat. Big tree, is it?
It's way in.
Who knows? We have all kinds of critters here. It could be anything. It could be a raccoon. They're usually not out in the day. Everybody's going to look.
That's more.
It's fun to live on the river. All kinds of critters. Y'all can see the big squirrel nest out there, right? That's pretty new. Somebody worked on that this week. Yep. Well, we took all the lower branches off over the summer, which gave us a clear view of the water that we didn't have before. Did I tell y'all that? So you had these dudes come and they climbed up till they could see the windows of the house. Guys, fight. And then they took all the branches off. So now the squirrels have to go up higher, but we can really see them and it's kind of cool. This is the time of year they really build their nests because they don't want to be cold all winter. I wonder what it was, James. It could have been
You guys have possum?
probably. Usually possums and raccoons are out at night, but we have those. Have you seen the pileated woodpeckers before?
Yeah.
Those are like the woody woodpecker. They're like huge. Okay. Oh, well, who knows? All right. So back to plutons. So plutons are when you have magma fill up certain areas and they make a specific kind of structure. And these are actually really kind of cool. So as this magma flows, right, and it melts the rock around it, it can eventually cool if it gets far enough away from the heat source that's below it. Okay, so when that happens, it'll solidify in these weird shapes. So you have ones like this called laccolith, lopalith, dikes, stocks, batholith. It can be pretty interesting. So, yep. So these are the types of things you're going to find. So let's look at them for a minute. All right. Anybody want to guess what batholith means? Want to break it down? Any part of that word? All right. What do you think?
I know lith means stone.
Bingo. All right. Anybody want to guess what bath is?
Like a big bathtub.
Like a big bathtub. Yeah. So it's actually means deep stone. So again, you got Greek and Latin that tend to get tossed in there. So these are specific name. Are you guys gonna? I still don't even see it.
I don't know which tree they're
You
talking
don't
about.
see it when it's moving because of the color.
Okay.
So if it's not moving, you won't be able to see it.
That's crazy. My neighbor has a trail cam down there, so maybe he caught it. He's caught a bear. And he had, one day he caught a shirtless man with a machete and a beer. I don't know what happened. He did. He sent a picture. It was the shirtless guy with, and he was a big dude. And he had no shirt and a machete and a beer can. And he caught him next to
That's an immigrant.
he's like, did you hire this guy? I'm like, no. Which is the second time we've had someone with a machete show up on our property with weird questions. So anyway, oh wait, so I was saying, these batholiths, these are your largest types of plutons, and they're usually found in big mountain ranges, and they cut across rock, okay? So we got types here. We got laccoliths and lopaliths. So yeah, what are we thinking? We got a word here and a word here. We know what lith is, because Alex already told us. What's lith? Stone, right? Okay.
Lacquer means small.
Okay, laccolith, do you think it's small? So laccolith actually means reservoir stone. I don't know why, but that's what they chose to name it, reservoir stone. Anybody want to guess what lopalith means? What do you think?
No.
Hill? Great guess. It's shell stone. Look at the shape. That one kind of makes a little sense. A little sense. I don't know who decides to name them. It's not me. Yeah, I would name it tree stump stone if it was me. So laccoliths, y'all good? So laccoliths tend to form near Earth's surface where they cause the rock to push upward in a dome shape. This one was probably more of a dome before it eroded, but it's pretty cool. And then a mass volcanic or igneous rock found within strata means layers, right? Which is spilled downward is what forms these depressions, and that's the lopaliths, okay? So then we've got, that means something? What?
You have a picture, go back.
What?
That's Close Encounters of the Third Kind.
This one?
Yeah.
Oh, really?
Called Devil's Butte, I think it's called.
I don't know. I don't remember Close Encounters of the Third Kind, but okay, that's a movie? Late 70s?
Yeah.
Okay, yeah, that's a movie worth watching. I don't remember that, but apparently this laccolith was in it. There we go. He's like, that means something. I'm like, what are you talking about? What was it? I
In
don't.
the movie, everybody, random people in the world got that image in their head.
Ah,
And one guy built it out of mashed potatoes on his plate.
I'm gonna have to watch this again. It's been years.
This is by aliens.
Yeah, I mean, if somebody's building mashed potatoes, they probably have been visited by aliens. All right, so
It's in Wyoming.
it's in Wyoming. All right.
Well, that's the bears town. There's a bunch of bears in that thing.
Oh, okay. Very cool. All right, so sills and dikes. All right. This is a word spelled two different ways, depending, and when you're talking about a structure, like a man-made structure, what's a dike, the man-made structure? What is it? What's another word for it?
It's normally I can't remember if it's like a small dam or if it's something in the dam that's got gates and like so you can open it.
It's a dam. Yeah, a dike is a dam, basically. So if you look at a dike right here, do you see how this is basically built like a dam? Like it goes up and down like this, and it would prevent any flow this way or that way. There's a whole like old nursery rhyme story about a little Dutch boy who puts his finger in the dike and stops the water from flowing. Old school story, very old. And then sills are exactly what they sound like. Think about a windowsill, right? Here it goes. This is a beautiful sill right here.
That's really cool.
That's very cool. I mean, look, you can see where everything around it has eroded and it's left this very obvious remainder of a sill. That's very cool. And this is a very obvious dike. And if you look at this dike, what can you tell me about this rock here compared to the rock around it?
It's much lighter.
It's lighter, so it's higher in
Silica.
silica. It's also not eroding as quickly. So if it's not eroding as quickly and it is a lighter color, yeah, it's more like quartz. It's exactly right. If it's more like quartz, it's going to erode a lot less. If you walk along any kind of like mountain trails or whatever, you see stones that people step on and erode, especially when they're like the kind of gray granite. Sometimes you'll find a vein of quartz that runs through it, and that vein of quartz is still sticking up higher than the rest of the rock, right? So then we need to talk about how these plates move and how that affects what's going on with the magma. This is also, by the way, a super cool dike. Look at that. I mean, it's really obvious, right?
Yeah.
I was trying to
So-
search the real DIKE.
Mhm.
What is a dike? 2 million times to Google and it's like DYK.
Yeah, you may find some interesting things if you look that up. So underground plutons can be brought to the surface but, as tectonic plates converge and push upward, exposing the rock within. So if you've got your tectonic plates, they're coming this way, and you've got a pluton of y'all, and you have a pluton of any kind, that convergence can force it upward, and then you can see it like this one right here. So it can be forced up to the point where it becomes super visible. And you can see this sill. That's a very obvious sill. Look at that. I mean, that's a completely different kind of rock there.
That's really cool.
It's very, very cool. So most igneous rock on the surface of the earth is not from volcanic activity, but from the slow, gradual process of plate tectonics. Also, there's a lot of erosion. We talked about Stone Mountain. It's a giant pluton, right? It's a batholith, I believe, technically. And there's obviously movement on our eastern coast, right? That pushes in. It pushes all the way to here, even if we don't realize it, it does. And over millions of years, that rock has scooted up a little bit because it's getting squeezed out. And then there's the erosion going on top, and suddenly we have a giant rock that we'll carve people and horses into, and then we'll have laser light shows.
So mountain was squeezed out here like a giant pinball.
Yes, exactly. It's like squeezing out a blackhead. You got it.
Getting taller.
Mhm. So if you watch Dr. Pimple Popper, that's what happens. All right.
I feel no remorse.
Yes. So now we're going to remember that batholiths get squished out like Dr. Pimple Popper. Thank you, Alex. All right. So moving on. Jace, we got lots of that. No worries. It's all good. Don't worry about the date. It's all good. Trust me. All right. So volcanoes. Let's see. All right. So anatomy of a volcano. The magma that erupts to the Earth's surface. What do we call it when it hits the surface, Liam?
Lava.
That's what we call it when it hits the surface. All right. And then we have lava erupting through an opening in the crust. And then we call that the vent. That's what it's coming out of, right? So then when it cools and solidifies around the vent, forms a mountain. And what do we call the mountain? Oh, everybody together.
Well,
Oh, guys, you're so smart. Look, I'll give everybody. Oh, Jack's not here. He doesn't get a coin. Sorry, Jack. I'll give everybody a little coin for yelling out the word volcano. Are we excited? Yes.
again.
Right. Ooh. Oh, no, Milo, he's not. Sorry, Milo. All right. So you get a volcano. All right. Volcanoes have different shapes and whatnot. Ah, why? That one's cool. Look at that.
That looks like someone sat down in it.
Has anybody ever seen, shh, has anybody ever seen the old animated The White Seal, which is a Rudyard Kipling story? At the end, the seal finds, it's a white seal, and he finds his place, his happy place, and it looks very much like this. It's in the ocean, clearly, but it's what's left of a volcano like that, and it's open in the middle and it's full of water. You ever seen pictures of ones like that? If you get looking, like really get looking in Google Maps along places where there's volcanic activity and there's strings of islands and whatnot, you can find some really neat stuff.
Is that a cinder cone?
It was at one point. Now we got a big old caldera sticking out there. So the top of a volcano around the vent is a bowl-shaped depression, and we call it oh, Chloe. There you go. It's a crater. So you got this giant crater here. All right. And these can fill up with water and become lakes. Or if they're in the ocean, they just become like these little tiny, almost like a little ecosystem all to itself, which is pretty cool. All right. So we got our different types. Here they are. Look at all these guys. Ooh, fun shapes. So the appearance of a volcano,
Right?
huh?
Is there only 3?
Yeah, but there's variations on the 3. So the appearance of a volcano is going to depend on 2 factors. One is the type of material that forms it. Is it more lava? Is it more ash? Right? Because some of them just poof out ash a lot, right? And the last one is the type of eruptions that occur. Is it magma that comes out nice and slowly? Or is it magma that comes flying out and shooting into the air? Right? Like Krakatoa pictures. You ever seen that? Huh?
Yellowstone.
Okay, yeah. That's a lot of water there. Yeah. So here are our 3 main types. They're going to be some that are a little different. So what does the word composite mean? Anybody know what composite means? Like, can you describe something that's composite? Anybody, Alex?
Composite resin.
Okay, so what's that?
I believe it's like multiple different types of resin that we mix together.
Yeah, composite.
Like mixture.
Yes, a composite's like a mixture or a combination of something. You might hear it like the Trex decking out there is the type of composite. Anybody have a white filling in your teeth? A white one? That's called, they call that composite filling. Do you remember what do you know what the silver ones were called? That's amalgam. And that means like, it's like a mixture, but it generally refers to like a mixture of metals. So it's an amalgam. So anyway, you have composite volcanoes, which means it's kind of like the other 2. So if you look, guys, y'all quit. It's kind of similar to the other 2. You got these cinder cones that spit out ashes and make this nice little, perfect little cone shape. You got the shield ones that have lava flowing out. And then you have these composite ones, and they tend to have lava that kind of goes out and spits out on the side sometimes on the top. They're kind of a mixture. So let's look at the shield volcano. All right. So we just said there were 3 main types, right? We said there were composite, cinder cone, and shield. So this is the big wide one, right? So your shield volcanoes are wide. They're mountains. They have gentle sloping sides and a nearly circular base. So they result from what kind of eruption am I looking for here? Results from the what eruption of what kind of lava that builds up in layers? Bailey. Weak's a good word. Okay. Yep. We're going for slow. There you go. And basaltic. Bailey, great job. How do you know it was basaltic?
Did it grow far?
Yeah. Go slow. Nice and slow.
Spread out decently far, babe.
Yep. Yeah. It didn't. It was thin and less viscous. So it
It is running like mucus when you're sick.
Yes, that's a good one. When your nose just runs as opposed to when you sneeze and it comes flying out. All right, very good. So an example, Hawaiian Islands.
Yes, my grandparents.
Went out, shh, hang on back there. Side conversations. What were you saying, Liam?
My grandparents were there.
They live there or they're visiting there?
They are there now.
Oh, wow. They're in Hawaii.
Yeah.
I've never been, but it's on my bucket list. So, there's lots of them. All right. So here's your cinder cone. That is a great picture of a cinder cone.
That's really beautiful.
I mean, it is. And it's, you can see all the dust and ash that's made it. So they're very steep. And it results from the material being, what's the word I want? Straight up in the air and falling back. Drew. Exploded. What happens when a pilot needs to get out of a plane in flight? There you go. All right. So it's ejected. So it's ejected. It shoots out, shoots up, right?
Say all the passengers panic.
I was talking when you're by yourself. Also, does anybody around here live close enough to see the stunt pilot that's local here? So there's a stunt pilot that's local here. I think he takes off at Stony Point, which is a small private airstrip. Those people have houses with hangars. Like, it's pretty cool. But if he's ever out when we're in class, we're going to stop what we're doing and go out and watch him because it's a physics lesson. But he has a single engine plane, and you can tell when he's out because you can hear, it's like the Doppler effect. Yeah, and then it stops and it comes again and it goes, but he will go straight up and he will like barrel roll, and then it'll cut the engine and it'll fall and then it'll catch it again. It's like going to an air show, but it's in your backyard.
Kind of dangerous.
Yeah, but I don't know if he can eject is my point. That's what I'm getting at.
No.
So this material goes straight up, falls back down, makes this perfect little cone. So your magma and your lava contain somewhat that make the eruptions explosive. What makes eruptions explosive? Piper.
Gases?
There you go. All right. When you have gases in there, they're going to be more explosive, right? That makes sense. Do you guys remember when we had the little test tubes and we heated them up and they would pop, 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 pop everywhere? All right. Yeah, we formed a lot of gas real quickly and it came flying out and it was less viscous. And I think in chemistry, we did one with salt. It was a salt solution and it popped everywhere because it was even more viscous. So it like shot really high. We had to slow it down. It was a little scary. And then you got your composites. Okay, so your composite volcanoes. Oh, did I say what an example was? Thought I did, but I didn't. Okay, composite volcanoes.
Is Vesuvius an example of a?
I think it is. I think you're right.
Just from the type of eruption that's wiped
Yeah,
out.
I think it is. Yeah. And I think a lot of the ones along like the Indonesian, that whole area, I think you see more of them there. So you get your larger versions of cinder cones that have been made of layers of what and solid material. What's going on? Yeah.
Tephra?
Tephra is a good one. Yep. So lava, tephra. What's tephra? You tell me.
The things coming out of the volcano, ash, dust.
Yeah. Tephra is
Bomb, volcanic.
Tephra is basically whatever the volcano blows out and it solidifies in the air and comes down. So it can be ash, it can be rocks of different sizes. Yeah, there are bombs. We'll get to that in a minute.
Wow.
So the magma or lava that makes them up is full of gas that builds up until it finally, whoa, this is easy, until it finally what? Liam?
Explodes.
Explodes, erupts, kaboom, it goes, right? So this stuff, all this pressure builds up, you got gas that comes popping out of there. All right, Mount St. Helens is an example. So Mount St. Helens is the video I want to show you guys later if we get the chance. And somewhere I have a baggie full of ash from Mount St. Helens, and I looked for it for like half an hour before this class, and I could not find it, but I will find it. Guy at the antique mall that sells like rocks and gems had little bags of Mount St. Helens ash. Oh, never mind. Okay. All right, pyroclastic material or tephra. All right, this is what Yusuf just brought up. They're the same thing. You can call it one or the other. Oh, that's fun. I love it when I forget that this thing's in the way here. So rock fragments thrown into the air during eruption, we call them tephra. And click, they're classified by size. So we've got this stuff right here. Yep. Guys in the way. All right, what's that? What do you suppose that is?
Well, it's a white powder of some
Mhm.
sort.
It's dust and ash.
White powder and stuff.
Yeah, it's dust and ash. The bag I have with Mount St. Helens ash looks just like this. It's a little darker, but it looks just like that. All right, and then next you're gonna have, oh, and by the way, this is a little aside, but volcanic dust and volcanic ash are the same thing. All right, so volcanic dust, sometimes they say it's more for powder sized material, but they basically mean the same thing. So then you get these guys. All right, what is that?
Volcanic block.
Yeah, well, this is lapilli. Anybody want to try and tell me why we would get lapilli? Anybody have any guesses? Does that remind you of anything? Yeah.
They look like volcanic boogers.
Oh, okay. There's that. That was helpful. What were you gonna say, Bailey? Before your twin brother stole whatever was in your mind, because I think he knew your hand was raised and he was just gonna throw that at you. So there is a stone called lapis, and sometimes you hear this LAP in reference to stones. Do you know what they call it when people get their kidney stones removed?
Laparlosis?
They have a laparoscopy and they have a lapilotomy.
Does it mean kidney?
No, it's just another little like rock thing. So lapilli literally means little stones. So you got the lap and then the ili, little stones, right? In Latin. And they're anywhere 2 millimeters to 64 millimeters, and any bigger, they're volcanic bombs. And then we have two types of bombs. We have blocks and these bombs. So blocks, okay, this is a person standing next to one. Imagine for a moment that flying through the air and landing somewhere, right?
In your house.
And following your head.
Yeah, I mean, that this is the bomb down here. This is the bomb down here, and it's about a foot long. That would do major damage, but just imagine, like, oof, it's frightening. So a block is angular, and it's a rock that existed before being ejected. So it's a rock that was already formed and it's forced out. Whereas the bomb, this little guy, is rounded. Why is it rounded? James. Expand, you're right. What did it exist before the ejection? No. It was magma that turned to lava that flew through the air and cooled while it was flying through the air, and then it slapped on the ground.
And it's more angular because while coming in, yeah, like more rounded while coming in.
More rounded.
Because of the air affecting surface tension.
Yeah, and it's flying through the air. Yep.
Responds to the shape of raindrops.
Yes, very good. Similar to raindrops, hail, kind of, but hail goes up and down, up and down. Sleet. Anybody see the sleet on, when was that? It's that Thursday. We had some sleet, or Wednesday or Friday. I don't know when it was. It was Friday. There was some sleet. I drove in it. No, it's like, I don't know. I think it was, yeah. Yeah, this is true. All right, so pyroclastic flows. So these are violent eruptions, send out a wave of stuff, right? Gas, ash, tephra, and they can travel up to 400 miles per hour. And that's what we call a pyroclastic flow.
These are one of the most dangerous parts of a volcano.
Oh, yeah.
They can wipe out an entire town.
Yep, everybody seen Pompeii? Seen pictures of Pompeii? Yeah, years ago. Oh, yeah?
There.
Your grandparents are travelers.
Yes.
And they're
So-
near instantly cooking.
Yep. So years ago, when Cole was doing one of his first dual enrollment classes, he had to write about some historic something event. And he did one on the pyroclastic flows with Mount Vesuvius, but he had to include like all kinds of data. And it was really interesting when we looked at it. Yeah, Drew.
Smoke can also block out the sun and make it very, very cold.
Oh, yeah. And then what else happens to it? Does it stay above the place that exploded forever?
No, it's spread.
It goes all everywhere. It can actually, like, for example, if you have a volcano erupt thousands of miles away, it can change your sunset and your sunrise. They look different.
Krakatoa actually caused the temperature of the Earth to drop by a few degrees for a few years.
Yeah,
And it exploded.
they're big, they're huge. So where do they occur? All right, we talked about this a little bit, and we talked about how they tend to occur along boundaries. So distribution of volcanoes around the world is not random. Most occur at plate boundaries. What percent is convergent? What percent do you think occur around convergent boundaries? Bailey, what do you think?
50, 60%?
Bailey's gonna go for 50, 60,
I'm gonna guess
80.
Oh.
A lot of them are at convergent. So think about this. Why would there be so many when the plates are coming together versus when they're pulling apart, Drew?
Because when they come together, they go up like this.
And they're forcing things upward. So that magma is being forced upward, as opposed to when you've got plates that are, yeah, it's exactly what's going on at the sea floor, right? It's forming it itself. So then you get closer to 15% divergent. And I know these don't add up perfectly because there's this guy. Okay, this is non-boundary hotspots. So this is basically where your crust is thinner.
My God, Hawaii.
Hawaii's kind of at a plate.
a good example, Yellowstone super caldera.
Okay, is that a hotspot?
Yeah, and it's one
Right.
that if it erupts, basically North America's gone.
Yeah, would be bad news.
We'll survive on North America.
Bad news. I want it to.
At the very least, everybody in the US is screwed.
Good point.
Like it would wipe out life on the US.
It's actually very useful.
What's the problem? Rain from the ash spreading out and causing sun to just disappear.
And one of the problems with the ash, not just making the sun disappear, is when you inhale it, it's not
It's not.
soft. It's like little razor blades in your lungs. It's not great.
It'll cut your lungs up and stuff.
Right.
And
Moon walks.
yeah, it will
Can't breathe in.
most likely, when it comes off, wipe out life, most life.
Well, this is an uplifting conversation. So let's talk about
soon.
Convergent volcanism. So we said, back to here. So we said 80% occur along convergent boundaries. Okay, this is the big one. This is the big spot, all right? You get ring of fire. So these are, they're like a little Johnny Cash. So the plates are coming together and this is where the Pacific Ocean is. And this is the, guys, stop talking. So this is your ring of fire or your Mediterranean ring. And so if you look, it's all along the edge of this Pacific plate. And this side of South America and this western coast of North America, this is where you're going to find Mount St. Helens up here, long through Alaska, and then these little hot spots in the middle.
Why is there a plate called the Cocos plate?
It's just a smaller one. Now we have Earth divided into main big plates, and then we have smaller little plates within them.
I see like a ball near Japan.
Near Japan right here.
Near Indonesia.
Yeah, well, right here, this whole area, all these, this is like a string of islands, right? And these are all formed. These are all volcanic islands, like Hawaii.
I believe Japan is also volcanic island because Japan
I think it is, yeah.
constantly hit by earthquakes.
Poor Japan. Well, look at where it is. No wonder Japan's constantly hit by earthquakes. Look at it. Good gracious, that must be frightening. All right, so divergent. All right, this is the one that's less common. And this is where you've got your plates spreading apart, right? Divergent. And they create a way for the magma to come up. And we call these rift zones or mid-Atlantic ridge. We've been through this. We just did this last week, right? So the stuff that happens here tends to be kind of slow and it's pushing out, but it's not popping. Now, here's the cool thing about hot spots. Okay, hot spots occur, but the plate continues to move. So what you get are the Hawaiian Islands, for example. So they're not formed along a plate boundary, but instead found in an area where the mantle is unusually hot. It's called a hot spot. And the plates move over the hot spot. So you get this volcano that forms here, and then the plate keeps going. So there he goes. And then another one. Do what?
It forms more volcanoes.
Yeah, a low line of them as the plate moves. Yes.
I have two examples. One, Hawaii was actually formed by a movement. That's why
Yep.
there are multiple islands.
Yep.
While the plate moved. Two, that the hotspot I was talking about is gradually moving relative to the surface of the Earth towards the east. Well, more like the US is moving to the west, but if it was US was staying and it was moving, the hotspot would be headed eastwards.
So does anybody know what you call this string of islands, little volcanic islands? There's a word for it.
Island chain? Volcanic island chain?
Archipelago. Archipelago. You'll find that. Sometimes you'll see that. All right. So we're going to take a minute. We're going to go over some of this stuff. It's in your binder. So if you've done your work, this should be easy. We're going to answer a couple of these and then we'll have some time and I'll have you watch some of that Mount St. Helens coverage because it is fascinating. I'll give you a second. Actually, I'm going to fill up my water while you guys get out your answers real quick. That way you can follow along.
If you do all of that in days.
If you drop the nuke on top of it, if you concentrate around it.
You might be able to trigger the nuclear device, yeah.
Now, definitely nuclear targets not the time for me.
If China realized, yeah, that's like one nuke.
That's amazing. That's what technology will do now. That's enough. When did that crash? Was it like a couple days ago? Week ago?
A lot of different countries around the area.
Jason was just saying, because this is just what's going to happen now that we have technology that we have. But there was a plane crash in Nepal. Did y'all hear that? Very recently. Well, apparently somebody were they live streaming? Oh no, they got video from inside the plane. There were no survivors, but they got video from inside the plane of the plane crash. That's the kind of stuff we've never been able to see before, but with everybody with their phones now, it's creepy, but it's a little fascinating what you can.
Did it before they died.
Either that or they streamed it or I don't know, but I'll have to look it up, but that's interesting. That's where we're going with stuff. All right. So here's how we do it. for this one, I'm going to read, and when I get to the blank, everybody's going to answer together. And I'm paying attention to who's answered. That way I know who has done their work. I see 1, 2, 3, 4 people who haven't answered anything today. So you got to prove to me that you've done that binder work. So magmas are named after extrusive rocks. Everybody together, right? Basaltic, let me make this bigger. Would that be better? Some of you are like, why does it say? All right.
Whoa.
Basaltic magma forms when the rocks in the,
Upper mantle.
you don't have to yell it. We're all right here. Click. All right, click. Click.
It's probably gonna reveal 4 at once.
No, it's being, come on. Okay, because it did because I made it too big. Okay, upper mantle melt. This magma contains small amounts of silica and has low. All right, I see some of you answering that weren't before. This is helpful to you. Basaltic magma fuels relatively quiet volcanic eruptions. Andesitic magma forms from ocean crust and sediments. This magma contains about 60% silica and has an intermediate viscosity. So what kind of magma?
And the same thing.
This one here, the next one.
Rhyolitic.
Andesitic, we're still in andesitic. Andesitic magma fuels volcanoes with intermediate, sorry, I keep reading that wrong. Yeah, intermediate eruptions. All right. Rhyolitic magma forms deep beneath continental crust. This magma has the highest, don't yell, just answer, silica content of the 3 types of magma. It has the same composition as, here you go, granite, and has a high viscosity and flows slowly. What kind of magma produces? Rhyolitic magma produces very explosive volcanoes. It's thick, it's gooey, it's got a lot of gas, and when that gas finally makes it to the surface, it's gonna throw that gooey magma everywhere. So viscosity increases as temperature increases. That should say, whoops, sorry, that should say directly proportional. I wrote inversely there. I got to fix that. Hold on, this one's wrong.
I did it Walmart.
What are you talking about?
It's thick water.
Oh, so actually, yes. So actually, if listen for a minute. Yeah, if you have a swallowing problem, you can have your liquids thickened. It does make it easier.
Yeah.
That happened with my dad after his stroke. He had to have thickened liquids. There is a it's like a powder you can buy. It's called Thicket. There's a couple other brands too, which you can put it in anything. And it will make it'll make juice like a honey consistency or whatever, which makes it easier.
Buy thick water.
Yeah.
You can actually find it. I think
You
there's
can.
stuff at Walmart. I think you can buy it at Walmart.
D2O.
What's that?
Water.
Oh, I don't know it. So cooler magma flows more slowly than hotter magma, obviously. Hey, jinx. All right, magma high in silica has greater viscosity than magma lower in silica. Basaltic lava is less viscous, lower in silica, and flows faster. All right, true or false? Magma is a mixture of molten rocks, suspended minerals, and gases.
True.
All right, magma forms when rocks begin to melt. Pressure decreases with depth below Earth's surface.
No, do you not? No.
False. No.
Did you coffee this morning or something?
No.
Okay. No, this is a little more than normal him. That's why I'm asking. All right.
That's sugar, that's probably.
As pressure increases, the temperature at which a dry substance melt increases. You thought about it for a minute. Okay, wet minerals and rocks melt at a lower temperature than do dry minerals and rocks. True. All right. So what 3 factors affect formation of magma? Heat, pressure.
H2O.
Yeah, heat, pressure, and water content. Perfect. All right. The entire Earth's mantle is not a liquid due to variation in pressure along the thickness of the mantle. Also, since the mantle is a bad conductor of heat, some parts in the upper mantle may not receive enough heat. That's why there's not heat everywhere. And how is water present in rocks and minerals? It can exist as a solid, liquid, or gas trapped in rocks' pores, spaces, or as molecules trapped in crystal structures. Now, this is went over here, we mentioned about no river rocks for fire pits. It may start as a liquid inside a rock, but when you heat it up, it's going to become a gas, and then it's going to, or crack the rock. Yeah, you mentioned all kinds of stuff today. All right, so our little image here, we've got right there, they're showing us that magma can melt rocks it comes in contact with. They're showing right here that magma can fracture overlying rock. And then this one, they're showing right here that magma can cause blocks of rock to break off, and then it can throw them in the air.
It looks like it's it's an amoeba trying to absorb that upper rock.
Okay, so here are definitions. Intrusive igneous rock body is A, Pluton, says Yusuf, and that would be D, Pluton. All right, the largest Pluton is A, batholith, and that would be E, so that's right. Irregularly shaped Pluton that is similar to the batholith but smaller in size is A. There you go, that's A. Stop. A mushroom-shaped Pluton. What do you think? That's going to be C, laccolith. Pluton that is parallel to the rocks. There you go. That's a sill. That makes sense. Pluton that cuts across existing rocks. That's your dike. And then the process responsible for the formation of many Plutons is mountain building. Oh, and we're going to be doing that in like 2 weeks. All right. So these mountain building.
We're building a map.
I think it's like 2-3 weeks we do that lesson. So we got lava erupting through Earth's crust is your volcano. These are obvious. You guys know these. All right. So, all right. So composite, cinder cone, and shield. All right. Now you got to answer which one this is. First one was cinder cone. Forms when tephra are ejected into the air. All right. How about has broad, gently sloping sides and a nearly circular base? Shield. Forms when layer. Actually, I'm going to do this quick because I think that video, if we watch it, we'll have time to watch the whole thing if we start it now. Yep. So I will. So your answers are cinder cone, shield, 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 cinder cone, composite, shield, composite, cinder cone, composite, composite, and composite. And then I will let you guys read that one at home. So we did what Lab 18 was. We know what that is. So now what I'm going to do is I am going to put this video on for you. I'm going to try to see if it doesn't play well through the computer, I'm going to swap it over. Okay. So we'll see how it works here. So this is only going to be cool. Yo. It's only going to be cool if you guys can quietly watch it. If you start chitty chatting, I'll find work for you to do. Okay. It's just really cool. And there's probably some stuff in here that might help you with your homework. All right. So as long as we're quiet and watching and paying attention, we're good to go. Whoops, I got to take it off the silence. Hush. You got to love the 80s hair and glasses and stuff too.
Moved a little bit, and then, oh my God, the whole mountain took off. Spewing scalding rock and ash. It was coming toward us like it was being shot out of a shotgun. Unleashing deadly torrents of debris and mud.
I felt him grab me, pull me up on top of the log, and he just kept screaming to hang on.
And leaving behind a landscape of devastation and death. Yeah. Tonight on Minute by Minute, the Mount St. Helens eruption. March 27th, 1980, southwestern Washington State, 6:02 a.m. The sun rises over the Cascades Range, a chain of volcanoes situated above the Pacific Fault Line. Towering over the landscape is the 9,677-foot Mount St. Helens. Known because of its beauty as the Mount Fuji of the United States, the volcano has been dormant for 123 years. Hundreds of campers, hikers, and photographers are converging on the mountain for the weekend. It's also a work day for over 300 forestry workers. Near Spirit Lake, less than 5 miles from the summit, U.S. Forest Service Supervisor Kathy Anderson and her tree planting crew hear what sounds like a small explosion.
What was common around there, because of the private timberlands in that area, were road building and other activities. So we kind of assumed that that had been just stump blasting or something.
But in fact, Mount St. Helens has awakened from its long slumber with a small eruption of steam and ash, opening a 250-foot wide crater in the summit. Within minutes, word reaches the Menlo Park, California office of the U.S. Geological Survey, or USGS. On hand that afternoon is geologist Don Swanson.
We quickly packed our bags and jumped on the first flight up to Portland.
Despite the eruption, logging companies in the area keep working. The Weyerhaeuser Corporation grows and harvests trees for building materials and paper on over 68,000 acres of land on Mount St. Helens. The day after the initial eruption, the company dispatches helicopter pilot Jess Hagerman to fly over the volcano.
Right on the very top, the whole top, there was a little bitty crater, and there were these big cracks running horizontal around the mountain.
USGS scientists install more monitoring equipment at their main observation post, known as Coldwater 1. The eruption has been a minor one, but they see it as a precursor of a larger and potentially deadly event. One of them, a 30-year-old volcanologist named David Johnston, voices his fears to a network news crew.
It's probably heating up very quickly, and it was probably pretty good evidence that eruption may be likely.
The U.S. Forest Service puts up roadblocks closing the top of the mountain. 40 residents who live nearest the summit are evacuated. Underground tremors make the eruption of Mount St. Helens seem imminent. The governor of Washington declares a state of emergency. Because rapid evacuation might be necessary, tourists and sightseers are urged to stay out of the area. But the warnings have the opposite effect, and tourists pour in from around the country. Souvenir vendors hawk t-shirts and bottles of genuine volcanic ash. Some volcano enthusiasts try to get as close to the summit as possible. One of them is Robert Rogers, a 29-year-old radio technician with a passion for mountain climbing. He makes a game out of outwitting the sheriff's department.
I would drive up and go,
Oh, is it really dangerous up there?
Oh, yes, son, it's very dangerous.
Oh, the people try to sneak in?
Yes, we saw a guy up there 2 mornings ago in a blue sleeping bag.
Really? Why did you do that?
and then explain what they did to try to catch me. Because I was the guy in the blue sleeping bag.
For geologists, however, watching the mountain is no sport.
You just didn't have time to do anything but eat and sleep and work.
Clear weather brings out a record-breaking number of tourists and television crews. News choppers airlift reporters to the summit, ignoring the danger warnings. They are rewarded with 18 small bursts of steam and ash throughout the day. 4 weeks after the initial eruption, scientists discover an alarming bulge on the north side of the mountain. Magma, rising within Mount St. Helens, has encountered a blockage in the mouth of the volcano and is being forced out around it. Scientists, like volcano hazard specialist Dan Miller, explain the danger to emergency agencies, but little is done.
As the weeks passed and nothing serious happened at Mount St. Helens, it became more and more difficult for us to convince the various agencies, both state, federal, and local, that something ugly was about to happen.
Over the next 2 weeks, the bulge on the north side of Mount St. Helens grows larger every day.
The mountain was moving at such a rapid rate, about 5 feet a day or so horizontally, just day after day after day after day.
Officials finally heed the scientists' warnings and establish a so-called red zone, a safety perimeter that extends from 3 to 8 miles around the summit. They begin evacuating residents. On the banks of Spirit Lake, less than 5 miles from the summit, an 84-year-old resident named Harry R. Truman, no relation to Harry S. Truman, tells reporters he has no plans to leave.
That's my life. Spirit Lake and Mount St. Helens is my life, folks. I've lived there 50 years. It's a part of me. That mountain and that lake is a part of Truman, and I'm a part of it.
Truman's defiance of authority makes him a folk hero overnight. May 1st, 1980. A month has passed since the first eruption. Without another major event, public excitement dies down. But the ominous bulge on the mountain continues to grow. The U.S. Geological Survey sets up a new observation post, Coldwater 2, 5 miles northeast of the summit. This one is 3 miles closer to the volcano than the existing site at Coldwater 1. At Coldwater 1, Rove Finley, an assistant editor with National Geographic magazine, is interviewing 27-year-old photographer Reed Blackburn when the ground begins to tremble.
I looked at Reed without saying anything, but with concern, he said, earthquake, I think it's about a 4.5.
The earthquake is just one of many that occur each day on the volcano, but any one of them could trigger an eruption. Blackburn, on assignment with the Vancouver Columbian newspaper, is ready if the mountain erupts. He is positioned where he can trigger 2 remote control cameras placed 1 mile from the summit. A graduate student manning Coldwater 2 must leave for the weekend. Geologist Don Swanson and his colleague David Johnston agree to take turns filling in for him.
Dave said, okay, I'll do it for Saturday night if you can come up on Sunday and replace me.
May 17, 1980, 8 a.m. It's been more than a month and a half since the first eruption. Despite the fears of USGS scientists, many of the residents evacuated from the red zone are convinced that the crisis had passed. They gather at the roadblock nearest Spirit Lake. Tempers flare as they try to return to their homes.
We're paying taxes and we'd like to use our property, Ray.
Senator Dixie Lee Ray relents and gives them permission to visit their homes today and again on Sunday.
Everyone had to sign waivers, releasing the county from any blame for what might happen to them while they were inside the red zone checking out their property.
The beautiful day brings a number of campers out into the Washington woods. At Jericho Hole on the Tooling River, 25 miles west of Mount St. Helens, high school sweethearts of Edith Durgan and Roald Wheaton parked their car by a favorite fishing spot.
There were no other people around us at all, so we just listened to the radio and sat up.
Roald had hidden a bottle of champagne deep in their cooler, a surprise treat for Sunday night. 6 miles west of the summit, Ty Kernan, a ham radio operator, volunteering to monitor the mountain for the state of Washington, received a transmission from a fellow volunteer, Jerry Martin of Concrete, Washington. Martin has stationed his radio van at a perfect viewpoint, just 7 miles away from the bulging north side of the mountain. Backpacking with his wife, Lou, and their 2 young daughters, 3-month-old Tara and 4-year-old Bonnie, Mike Moore passes up 2 campsites.
This was Bonnie's first backpacking trip. We wanted it to be something memorable for her.
They find an ideal spot near the Green River, 13 miles north of Mount St. Helens. In Bear Meadows, 14 miles northeast of the summit, amateur photographer Gary Rosenquist and a group of friends set up camp after dark.
We had a real big fire because of all the wood that was around there, and just had a good time telling stories. It was just a beautiful night.
May 18, 1980, Swift Creek, 5:30 a.m. Tree planting crew chief Kathy Anderson informs her crew they will abandon their site near Clearwater Creek and relocate to Swift Creek, 6 miles south of the summit.
I'm still not certain what caused me to have that thought. It was out of the norm for us to stop working in one area and go to another when we weren't finished.
One member of her crew, Cran Kilpatrick, is surprised by her decision.
We were actually going to someplace much closer to the mountain than where we were on Saturday, and potentially even a lot more danger.
As the sun rises over Mount St. Helens, Jim Skamanki and a 3-man thinning crew begin cutting saplings 13 miles from the summit. 100 miles away, at the airport in Yakima, Washington, a Cessna 182 takes off on a reconnaissance flight over the volcano. On board is geologist Dorothy Stoffel.
It was my first time to fly in a small plane, and I was a little anxious about it, kind of unsettled, and really not knowing what to expect.
At the USGS office in Vancouver, 40 miles from Mount St. Helens summit, geologist Don Swanson is waiting for colleagues to arrive.
People were going to bring me supplies that I could take up to live from when I was up at Coldwater 2.
Volcano hazard specialist Dan Miller starts out on a 2-hour drive to Coldwater 2. He's bringing supplies and parts for the 2 time-lapse cameras.
I drove over to the battery shed and picked up all of the batteries that I had on the charger overnight.
Nearly 8 miles west of the summit, Robert Rogers and his friend Francisco Valenzuela arrive at the Sheep Creek Overlook. They have just finished another illegal climb. They park near ham radio operator Ty Kearney.
He looks up and says, well, where were you boys this morning? We made up some story of driving around. We didn't want to tell him we'd gone into the red zone.
8:30 a.m. Just above the summit, geologist Dorothy Stoffel is taking photos of the volcano.
We were flying directly over the South Crater Wall, about 500 feet. And as we went over the mountain, I took pictures of Harry Truman's Lodge.
Lou Moore is making breakfast at her family's Green River campsite.
Tara had been brought out of the tent and sat next to where Lou was working. Bonnie was wandering around. I was wandering around.
I was hanging out down in the room with the seismographs.
We dropped John off at his unit and his crew, and they started to plant their trees.
I was heading up Interstate 5.
We made a decision, we'll make one last pass.
1 mile beneath Mount St. Helens, an earthquake measuring 5.1 on the Richter scale shakes the mountain, setting in motion a terrifying chain reaction. Mount St. Helens erupts with an explosive fury, next on Minute by Minute.
Oh, yeah.
And now back to Minute by Minute. May 18th, 1980, Mount St. Helens, Washington, 8:32 a.m. An earthquake measuring 5.1 on the Richter scale rips through the core of Mount St. Helens.
We began to see this enormous fracture open up. It was as though you were slicing the mountain in half. The whole north side of the mountain began to shake.
Seconds later, like a zipper, from east to west, these little brown detonations, poof, 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 zipped right across the top of the mountain.
Suddenly, I just looked up, heard some sound, and looked up, and here was this tremendous.
So the ground moved a little bit, and then, oh my God, the whole mountain took off.
25 seconds after the earthquake hits, a huge explosion bursts out from the north face of Mount St. Helens. Superheated gas shoots rock and ash more than 12 miles into the air. Dorothy Stoffel's plane is dodging deadly jets of hot gas and ash. Her pilot thinks fast.
He's diving the plane to try to gain speed to outrun the blast and watching the ground coming up from below and thinking he's going to nose this plane right into the ground.
On a ridge less than 8 miles from the explosion, Robert Rogers runs to grab his camera.
I get back to the car, quick open the door, drop a roll of unexposed film, and start shooting really fast. Click, 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 jam. I got 6 shots and my camera jammed.
In Bear Meadows, 14 miles to the northeast, amateur photographer Gary Rosenquist grabs his camera and snaps 23 photos in just 30 seconds.
I couldn't concentrate on viewfinder, so I started taking photographs again. I kept taking photographs till I ran out of film.
David Johnston, who is at Observation Base Coldwater 2, less than 6 miles from the blast, radios into the USGS office in Vancouver, Washington. He gets out one short statement, Vancouver, Vancouver, this is it, before the radio goes dead. All the while, ham radio operator Jerry Martin is broadcasting from a ridge 2 miles farther north. Martin watches in horror as the USGS observation post at Coldwater 2 is swept up in the enormous slide. Jerry Martin signs off. He is never heard from again. 8:33 a.m. 2 more huge blasts of gas and rock shoot out as the northwest side of the mountain crumbles. The eruption covers a 230 square mile area and dumps 200 feet of rubble into Spirit Lake and onto Harry R. Truman, killing him. Above the mountain, Dorothy Stoffels' plane banks south and pulls away from the blast. Dorothy looks back to see the top of the mountain torn open by a force 500 times greater than the atomic bomb at Hiroshima.
We saw this huge blast cloud lift up. And as it lifted up, there was lightning, tremendous lightning bolts going tens of thousands of feet high.
At the Coldwater 1 camp, 8 miles from the summit, photographer Reed Blackburn jumps into his car and guns it, desperately trying to outrun the cloud of ash. It's too late. In seconds, his car is engulfed. Blackburn is suffocated in 4 feet of scalding ash. The wind is so powerful that it uproots 100-foot trees as far as 19 miles away. 8 miles from the summit, Francisco Valenzuela and Robert Rogers jump into their vehicles and screech away.
Our clothing was like in a gale, just blowing. It was like a freight train with 10,000 square wheels just going by. It was the loudest noise I'd ever heard.
6 miles south of the summit near Swift Creek, Fran Kilpatrick's Forest Service crew is running for their lives. Kilpatrick and Kathy Anderson are waiting in their truck at the top of the ridge, ready to lead the evacuation. They can only hope to get their team out before the cloud of burning ash and steam envelops them.
You could see these things periodically shoot down the south slope. They were coming straight at us. If we had been a half a mile closer, we would have been torched.
What Kilpatrick and his colleagues don't yet realize is that if they had stuck with their original plans to work on the north side of the mountain, they would all be dead. Still, the crew is far from safe. Laden with tools, they are slow to climb the steep slope of their vehicles.
Kathy calls on her radio, "Dump all the equipment, let's get out of here."
Minutes later, everyone reaches their trucks and drives to a rendezvous site where they wait for word on a safe evacuation route from a spotter plane.
You can just see the debris going overhead. And we had lightning around us.
USGS geologist Dan Miller is on Interstate 5, 15 miles southwest of the mountain. He's on his way to meet David Johnston at Coldwater 2 when he sees the eruption column.
I realized immediately that this was really a huge and very serious eruption. I quickly crossed over the median on Interstate 5 and I went racing back into Vancouver.
13 miles north of the summit, Mike and Lou Moore and their daughters, 3-month-old Tara and 4-year-old Bonnie, look up to see a tremendous cloud towering over the trees. Mike grabs his camera.
The more pictures I took, the more apprehensive I got because the blast was not going up. It was coming toward us like it was being shot out of a shotgun.
The ash, hot enough to burn skin on contact, is surging down the mountain at a rate of up to 300 miles an hour. 11 miles southwest of the summit, Robert Rogers is in his car, following Ty Kearney's van down a winding mountain road. The group is trying to outrun the cloud, but in the ever-thickening haze, Rogers loses sight of the van. Kearney goes on to safety, but Rogers and Valenzuela are stuck in the swirling ash.
The second time we passed this gigantic Caterpillar tractor in the dark, we knew we were lost.
High above them, Dorothy Stoffel is in a small airplane, hoping to put some distance between herself and the mountain.
We began to see this huge grouping of aircraft rushing towards the mountain, and we thought, just like the media, they're going to get there as fast as they can while we're trying to leave.
Stoffel lands 40 miles away in Portland. 13 miles north of the summit, the Moore family is hit by a shock wave.
We felt a squeezing of our bodies, a very tight squeezing. And Ruth said this didn't happen to her, but my ears popped repeatedly, just pop, 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 pop.
40 miles away in Vancouver, the phone rings in National Geographic editor Ro Finley's hotel room.
It was Ralph Perry, one of our contract photographers. He said, "Ro, if you'll step out the door of your motel and look to the northeast, you can see Mount St. Helens filling the sky."
At his home in Kelso, Washington, Ray Pleasant, a helicopter base manager for the Weyerhaeuser Corporation, is still in bed when he hears a knock at the door.
Our neighbor, she used to monitor the ski or the scanner, and she found out that the mountain had erupted.
Although his logging crews are outside the red zone, Pleasant needs every available chopper in the air for possible rescues. He immediately heads out to the nearest base. On a small farm 37 miles from the summit, Jess Hagerman, a captain in the National Guard, is getting ready for church.
They called me to call and find out how many people we had that were able to fly.
Hagerman immediately heads to the Air National Guard base at Fort Lewis, 20 miles away. The vertical column of ash and steam continues to expand upward and outward. 13 miles away at the Green River campsite, ash begins to rain onto the Moore family. They take cover in a dilapidated hunter's shack, but it affords little protection. Mike and Lou Moore's primary concern, keeping their daughters alive.
We gave Bonnie a handkerchief that had been wetted down with water from the canteen. Well, it wasn't gonna work for Tara, she's 3 months old. So what we did is we wrapped her up in blankets. At one point, Lou went over and pinched her because she was so quiet. She thought she was dead and she wanted her to cry to prove that she wasn't dead. We were all very relieved to hear that cry.
The intense heat from the volcano melts the mountain's ice cap, sending 46 billion gallons of water into the Toutle Valley below. Mudslides, heated to 91 degrees and moving at 90 miles per hour, rush down the mountain. 25 miles from the summit, along the south fork of the Toutle River, high school sweethearts Roald Reedon and Venus Durgan hear the sound of warning sirens.
We just pulled the tent right out of the stakes and ran up to the car.
Roald guns the engine of his Oldsmobile, but it's too late. The engorged Toutle River is now raging toward them, carrying logs and debris from nearby lumber yards.
Surrounded the car and picked up the car. And at that point, the first instinct was to get out of the car, but there was no place to run.
Their car is engulfed by the flood. They jump from the vehicle into the swirling mass.
I was lucky enough to land on a large log and Venus went right in between. The one I landed on another one and was gone. Instantly gone. So I thought she was dead.
The couple and hundreds of others on the mountain fight to survive. Next on A&E. And now back to Minute by Minute. May 18th, night on St. Helens, Washington. 9 a.m. Mount St. Helens has erupted with the force of 10 megatons of TNT. A cloud of scorching ash mushrooms 15 miles into the air. 25 miles away, along the south fork of the Toutle River, campers Roald Reedon and Venus Durgan have been swept away by a deluge of mud and logs. Venus loses sight of Roald as she is sucked down into the morass.
I could hear him screaming in terror. I kept my hands and head above water, and at one point, 2 logs started pinching my wrist. I thought I was going to lose my arm or my hand. The pain was excruciating. At that point, I thought it was over.
Roald, clinging desperately to a log, sees Venus's hand reaching out between 2 massive timbers. He lunges for her as the logs close in around her.
They were moving up and down and sideways, and it would just like peeling skin off her chin.
I felt him pull me up on top of the log, and he just kept screaming to hang on.
Finally, after a terrifying mile-long ride, Roald maneuvers Venus across the logs and onto the banks of the river. Venus's wrist is smashed, and her right forearm is stripped down to the muscle. She is going into shock, and Roald knows that their only chance of survival is to keep moving.
I like this video.
9 miles from the summit, tree planters Cran Kilpatrick and Kathy Anderson have been waiting for 30 minutes with a convoy of Forest Service trucks. They're hoping a spotter plane will arrive soon to scout a safe route off the mountain. They are in constant danger of being engulfed by burning ash. As the crew waits, tension builds to the breaking point.
There's one guy started to run. We actually literally had to grab him and throw him back into the van.
He got hit, mostly just gonna knock some sense back into him.
Finally, word comes over the radio that the ash is still too thick to allow a spotter plane to fly into their area. They'll have to find their own way out, driving across the bridge of the already swollen Swift Creek.
I ran out onto the bridge. What I wanted to do is see if a mud flow was coming down the Swift Creek. There wasn't one coming, so I signaled everybody across the bridge.
Ash is raining down heavily as Kilpatrick jumps into the last vehicle on the convoy. Just on the other side of the bridge, his truck stalls.
This truck in front of us just disappears into the cloud. We didn't see anybody. It was like, oh my God, we're alone here.
Kilpatrick radios Anderson, and she hurries back to pick him up. The convoy slowly makes its way down the mountain to safety. 2 miles from the summit, geologist Don Swanson is flying in a Forest Service plane, searching for his colleague, David Johnston.
There was not much chance that David or anybody else in the area was going to live through it.
Heading toward the mountain in a Cessna, Roe Finley hopes to reach photographer Reed Blackburn at Coldwater 1.
And flown over cities bombed and burning during the war, but this was so much more awesome.
The wind shifts and the ash cloud heads east, a welcome sight to the Moore family, who are hiding out in an old shack 13 miles to the north of the volcano.
I decided it was time to go out and see what I could see outside. Unfortunately, the door was blocked with 6 inches of ash, and it took quite a bit of kicking to get it open. I could make out the outline of a tree, and that's when I started feeling pretty good.
Lou Moore carries 3-month-old Tara, while Mike Moore gathers up 4-year-old Bonnie. He shoulders the backpack containing their tent, food, and survival equipment. On a logging road 8 miles from the summit, Robert Rogers and Francisco Valenzuela are lost in the haze of ash. Then,
Way behind us out on the west, a little pinpoint of light. That little spot of light got bigger and bigger and bigger.
as the air slowly clears, Rogers and Valenzuela are able to navigate their way out. The ash cloud reaches Yakima, Washington, 97 miles to the northeast. Though no longer hot, the ash makes it difficult to breathe.
This is, of course, the source of the big problem, the volcanic ash buildup. I'd say the buildup now is at least 3/4 of an inch.
Residents must shovel off their roofs to keep them from collapsing. A weather satellite captures photos of the ash cloud as it stretches across Washington state and reaches Spokane, 200 miles to the northeast of Mount St. Helens. It has taken nearly 3 hours for badly injured campers Roald Wheaton and Venus Durgan to struggle through the dense forest.
I knew we had to go upstream because we floated underneath the bridge. I figured if anybody was going to be anywhere, they'd be there. And there was a sheriff's car on that bridge.
The sheriff's deputy radios for a helicopter evacuation. Nearly 4 hours after the first explosion, the eruption is still going strong.
Fresh magma was rising up and was escaping from the volcano.
Jets of burning gas sweep down the flanks of Mount St. Helens at up to 80 miles an hour. 11 miles from the summit, Mike Moore and his wife Lou try to get their young daughters to safety. Weighed down with survival equipment, Mike comes to an area of blown down trees 6 to 12 feet in diameter.
I couldn't carry Bonnie. Lou couldn't carry her because she had Tara in her backpack, and Bonnie was basically on her own in between us. She's a pretty tough kid, but for 4 years old, you're asking an awful lot.
The Moores struggle to keep their children alive as rescuers search frantically for stranded victims. Next on Minute by Minute. Now back to Minute by Minute.
What?
May 18th, 1980, Mount St. Helens, Washington. 12 p.m. The mountain has now been erupting for 3.5 hours, sending a total of 490 tons of ash hurtling over an area nearly the size of West Virginia. Emergency services estimate at least 3 people are missing and 7 are confirmed dead. Area hospitals filled with injured, suffering from ash inhalation and burns. Rescue teams searching for survivors find they can't recognize a single landmark. The rescue operation is a dangerous one.
Getting tired of the kid, we need to be carefully maintained.
Chopper pilot Ray Pleasant and his crew respond to an emergency call near the Tougal River. When they arrive, they find Roald Wheaton and his badly injured girlfriend, Venus Durgan. The crew jumps out and loads Venus in. Pilot Ray Pleasant pulls back on the controls and heads out of danger.
I was able to look back. I just saw this brown body, tiny little brown body in the back with the big eyes looking at me, and I'm just scared.
A second helicopter airlifts Wheaton out. The choppers fly across the river to the town of Tougal, where a medevac unit has been set up at a school. 14 miles from the summit, the ash is so thick it is almost impossible to see the ground. National Guard chopper pilot Jess Hagerman flies his OH-58 back and forth over the terrain, searching for Jim Skamanki and his forestry crew.
All of a sudden, we look down and we see some kind of a car or a truck down there. And so we swung around. One thing that you could see were footprints in the ash. So then you know that you've probably got some survivors.
The footprints diverge, indicating the 4 men split into 2 parties. Hagerman banks his copter and follows one set until he locates 2 of the missing men.
One of the people would stand up and wave his arms, and then, you know, he'd kind of fall back down, and the other fellow never really did get up off the ground.
Hagerman's crew chief, Randy Fonts, volunteers to go down after the 2 men, even though he has no idea what awaits him.
This stuff could have been 150 degrees Fahrenheit. We didn't have a clue. But so anyway, he gets out of the helicopter, gets on the skid, and jumps into this stuff.
The ash has cooled considerably, but it was scalding when it blasted over the stranded men. One of the foresters, Jim Skamanki, is burned over nearly half his body. His co-worker is sprawled on the ground near him, barely able to breathe. Hagerman lands the helicopter and hurries through 8 inches of talcum powder fine ash to help his crew chief evacuate the badly burned men.
When you touch their clothes, it was like if you scorch your clothes with an iron and you just pull it like that, it just shreds apart.
The 2 men are taken to nearby Longview Hospital, where they are treated for 2nd and 3rd degree burns and ash inhalation. An Air National Guard helicopter finds the 3rd member of the crew sitting atop a tree in the middle of a mudflow. He is rushed to the hospital, but the leader of the crew is still missing. Venus Durgan is at Longview Hospital receiving medical attention. Her wounds are filled with ash.
The nurses were crying because they had to immerse me in a tub of water and take sponges and scrape out my wounds. And when the doctor came in, he said, "You didn't do a good enough job." They had to take me back in a second time, and they had to put me on morphine at that point because I was in such pain.
Robert Rogers makes it out of the woods and stops on the I-5 freeway to look back at the volcano 25 miles away.
Everybody would stop on the freeway looking at the volcano saying, "Look, he's covered with ash." And I drove back to Portland, and that was it.
Now that the pressure within the volcano is relieved, the eruption gradually begins to subside. 200 square miles of forest have been destroyed. Heavy equipment lays plowed about like toys. 9.5 hours after the eruption, Venus Durgan's boyfriend, Roald Wheaton, is released from Longview Hospital into his parents' care. They find a hotel for the night, and Roald's father tries to scrub more ash from his son's wounds.
Oh, it hurt so bad. It was like I had passed out. I mean, God bless him, you know, he did a pretty good job, but you know, he didn't get it all out, so, you know, I'm tattooed in spots on my legs, you know, from where the ash got rubbed into my skin.
In her hospital room, Venus Durgan watches coverage of the eruption.
I laid in the hospital room that night, watching all the events on TV. My IV bottle in the hospital is shaking every time the mountain rushed.
But not everyone is out of danger. As night falls on Mount St. Helens, Mike Moore, his wife, and 2 young daughters have not been able to find their way out of the forest. They pitch camp for the night, but Mike cannot sleep.
And we could hear the volcano exploding and crackling, and like a witch's cauldron.
Let's see what's next on A&E. Where were you when Mount St. Helens erupted? Tell us at A&E.com. And now back to minute by minute.
So there's like 7 minutes left and 3 minutes till it's time to go. So at 1:30, if you want to leave, go ahead and leave, or if you want to just keep watching the last 6-7 minutes, you're welcome to do that.
Takes to the sky to continue the rescue effort.
I really didn't have a clue where I was. You couldn't see more than 1/8 of a mile, sometimes less.
When the ash does part, it reveals fallen trees stretching as far as the eye can see. Despite the devastation, rescuers still hope to find survivors. But as time goes by, they find themselves placing more and more red flags to mark the dead. One family on the mountain has survived the eruption. Mike Moore, his wife Lou, and their 2 children have spent 26 hours in the forest near Mount St. Helens, unable to make their way safely. Suddenly,
Here comes the helicopter, flying in our direction. And the 304 squadron out of they put 2 paramedics on the ground.
the Air Force team tries to air.
Oh, stop it. Come on. 1, 2, 3. Making it.
They don't know if it was in the field.
Cable rescue was impossible. We'll have to find a place to touch down. The Moore family and the paramedics hike to the Green River, but find no room for a landing there either. At that moment, Air National Guard chopper pilot Jess Hagerman flies over. He radios the rescue team and offers to use his smaller craft to evacuate the Moores.
There was no place to set the helicopter all the way down, so I had to kind of hold it on one skid.
The Moores, who have their 3-month-old daughter